We are going to proceed on the series of pharmaceutical calculations, and today we shall be looking at the concept of density and specific gravity. These concepts are very crucial in pharmaceutical sciences as they have different applications, especially during purification of drugs, during separation of drugs, during tableting, and more other applications. We all remember the concept on Archimedes' principle, which states that when a body is totally or partially immersed in a fluid, it experiences an upthrust, which is equal to the weight of the fluid displaced, meaning that in this sense, density will be equivalent to mass over volume, because we have the certain object immersed in a fluid. So mass in terms of grams and volume in terms of moles. And under normal circumstances, density will be equivalent to specific gravity. And an instrument which we use to measure the specific gravity of different chemicals and compounds is the glass plummet. So we have got few examples here for just 4 to 5 minutes on the concept of density and specific gravity. Mind you, whichever question you solve must have the certain components which have portrayed here on the board: mass in terms of grams and volume. If not, we need to have the density and do it otherwise. So let's begin with the first example. The first example is about the density. It says, what is the density of a solution which weighs 250 grams and 248 mils? So obtain the data. Weight in terms of grams, we have 250 grams. And volume, in terms of mils, we have 248 mils. So, mind you, density equals to what? Mass over volume, according to Archimedes' principle. What is the mass? This is 250 grams. Then we shall divide it to 248 mils. Then this is equivalent to what? 250 over 248. This is 1.0008. This is 1.0008. But this is mass over volume, so that is gram per mil. Okay, then the second example. What is the specific gravity of 365 mils of glycerol, which weighs 460 grams? Okay, here we are looking for specific gravity. Weight, the weight of glycerol, this is 460 grams, and the volume, this is 365 mils. There are different aspects of solving this question, but always specific gravity is equivalent to the weight of the substance over weight of equal volume of water. So this is one of the formulas used to solve this. Weight of a substance over weight of equal volume of water. Weight of equal volume of water. So in this sense, the substance is not water, but any other substance according to the question. And in this sense, any kind of weight or volume shall be switched into either or. So weight of a substance, according to this, our substance is glycerol. What is the weight? The weight is 460 grams. And weight of equal volume, that is 365 mils. Now you may wonder that this is weight, then that is unit is in mils, but mind you that this is the weight of equal volume. If you tend to divide here, then this is 460 divided by 335, and that is 1.26. That is 1.26. Now, mind you this, specific gravity has no SI unit because we are assuming this to be the weight of equivalent volume of water. So that remains plain. While on the other way around, density has got the SI unit of gram per mil. Okay. Let's have another example. We shall be solving 3 more examples. Now this question says, a glass plummet weighs 12.64 grams in air, 8.57 grams when immersed in water, and 9.12 grams when immersed in oil. Calculate the specific gravity of oil. How are we going to do this? Remember, as I told you, the glass plummet is an instrument used to measure the specific gravity of a substance. And we have different kinds of weight as expressed in the question, but some of the weight are not true weight. How are you going to do that? Check. This is a glass plummet. Now the glass plummet weighs 12.64 grams. This is when in air. When it is free, nothing is in. Then it weighs 8.57 grams when immersed in water. This is when in water. Then it weighs 9.12 grams when in oil. Now the question is, what is the specific gravity of the oil? Then this is our substance. This is your question. Mind you, this is not the true weight when it has water, and this is not the true weight when there is oil. So in order to get the true weight, you need to subtract the weights given from the weight which had contained air. So to know the true amount when it was in water, take this amount minus this. So when in water, that is 12.64 grams minus 8.5 grams. Then when in oil, take 12.64 when it was free in air, subtract 9.12 grams. What are we going to get? This is 12.64 minus 8.5. Then this is 4.14 grams. Then 12.64 minus 9.12. This is 3.52 grams. Let's go back to the formula. What does the formula say for specific gravity? Specific gravity, this is equivalent to weight of a substance over weight of equal volume of water. Weight of equal volume of water. Okay, what is the substance here? The substance is oil. Then this is 3.52 grams. Then weight of equal volume of water, this is 4.14 grams. Therefore, the specific gravity is equivalent to what? Divided by 4.14. This is 0.85. This is 0.85. I'm reminding you again that the specific gravity has no SI unit. So the general conclusion here we can obtain is that when the specific gravity is less than 1, then this means that this substance is less denser than water. Meaning when you mix the two substances, one substance with water, the substance, if it is oil or whatever, is going to float on top of water because the specific gravity is less than 1. Thus, this is helping us to predict before we mix substances. And if the specific gravity is 1 plus, that means that the substance to be mixed with water is denser than water. That is to say, water will float on top of the substance. Let's have one more example, then we quit the session. All right, if a liquid has a specific volume, listen to this. This is a logical test. If a liquid has got a specific volume of 1.396, then what is the specific gravity? So this question has only stated the specific volume, no specific weight, but you need to calculate the specific gravity. How do you do this? Check this derivation. There is the other way around to perform this calculation. Mind you that specific gravity is equivalent to specific weight over specific volume. So this can be derived as this. Specific gravity is equivalent to 1 over specific volume times specific weight. So if you really need to know the relationship between specific volume and specific gravity, then it can be obtained as follows. Specific gravity is inversely proportional to specific volume. Then this is a relationship between the two. So if you have the specific volume, automatically you may obtain the specific gravity. So specific gravity is equivalent to 1 over specific volume, which is 3.96. Then the specific gravity is equivalent to the inverse of the number 0.716. This is 0.716. That will be your specific gravity. So up to that moment, you may be performing other calculations, and at the end of the day, you shall be competent in the concept of density and specific gravity. Other questions have been portrayed, have been displayed on the projector. You shall solve them at your own time. Let's chip into the next station about the allegations.